Okay, this is Unit 7 review. We're picking up at question 22. So all of these next few questions are things to either add or subtract or multiply or divide, but there's not another side. There's not an equal sign and something else. So you have to just work with the expression that you are given. So for example, in number 22, I see that there is division. So for division problems, I know I like to rewrite as multiplication. I also am doing some factoring. So on the bottom, I had a difference of squares. On the top, I factored out a greatest common factor. Here, I'm going to switch to multiplying, and then the bottom goes up onto the top, and the top goes to the bottom. And the top has a common factor of 5. And now that's the denominator. So division is the same as multiplying by the reciprocal. So that is what I did. I multiplied by the reciprocal. Then I'm going to look for things that are common factors top to bottom, because everything here is multiplied. So I could think of it like one jumbo fraction. All of that smushed together. All of this smushed up together. And then anything that's on the top and the bottom would divide to equal 1. That is, something divided by itself is 1. As long as that something isn't 0. And then here, I'd have another common factor, and then that would just leave me with my answer. Those are the pieces that remain. Okay, in the next problem, we are subtracting. I know that when I subtract, I need a common denominator. I do not have that now. The first fraction would be the same denominator as the second fraction if it had x plus 3. So if I were to not have this problem number here, I would just be multiplying by x plus 3 over itself times that first piece. So that together is x plus 3 minus the 5 with a common denominator of x plus 3 and x plus 8 multiplied together. Then if I distribute, I have this lovely thing. And that top part does not factor, so I know I'm not going to be able to find common factors if there aren't any factors in the first place. In question 24, there's a lot of factoring that can happen. This top part factors. This bottom part, yeah, that even factors, right? X minus 2, x minus 2. Division is the same as multiplying by the reciprocal, so the part from the bottom is now going to be on top, and the part on the top will now be on the bottom. Notice that as I did that, I also, like I multitasked, right? I also factored out a GCF. Now there are going to be some things on the top that are also on the bottom. Everything is multiplied. Everything is multiplied. So it's going to be like one jumbo fraction like we had back here in question 22. So x minus 2 with x minus 2 would divide to equal 1. X minus 5 would divide to equal 1. And I'm just left with these little pieces. The x's here do not cancel because that is not a common factor. Even though this x is a factor, it's being multiplied, this x is not a factor. That x is a term because it has a subtraction associated with it. Okay, here are the answers a little more neatly, but I guess you saw that was the answer key online. All right, now we're to my favorite kind. My favorite kind is when we have equations. So when you have equations, you can do things to both sides because you have sides, right? You have an equal sign, a left side of the equation, a right side of the equation. So in 25, you can multiply on both sides by these denominators to clear the fractions. So I know, like last week when we were on this lesson, some of my students got in touch with me and said, we are really confused. We always thought that we just cross-multiplied. And in the video, you guys are showing us all this multiply on both sides by things, right? And it was super, like some people found that super confusing. Okay, so here's the thing. It works out the same. So in your brain, you can decide which one you want to do. Okay, so here, I'm just writing this with more space because I realized if I have that all squished, it's too hard to think about. Okay, I don't know what I'm using color here for. It's weird. Okay, so on the left side, I multiplied by the same thing as I did on the right. I happen to write it in red on one side and green on the other. I don't know what's up. Okay, so on the left side, you can see the x plus 3 is going to cancel. And on the right side, you can see the x, or 2x minus 1 is going to cancel. So I am left with 6 times 2x minus 1. And on the other side, I am left with 9 times x plus 3. And that's just awesome. Now, I'm going to erase all of that, and I'm going to show you that this is the same result you get with cross multiplying. Now, cross multiplying is a horrible term because even though you are multiplying, it's not a good cue in your head. It's very frustrating, I think. We should have a better word, but I don't really know what it would be. I try to emphasize the fact that when you have a proportion, right? So if you have a ratio, and they are set equal to each other, that's what's called a proportion. So something over something equals something over something. When you have that, then what you get multiplying top to bottom will be the same as what you get the other way, multiplying top to bottom diagonally. Okay? I don't really know a great name for that, but the result is this. Okay, and once we have this, that's awesome. Okay, now I would be very creative, and I'm going to write my steps going up because that's where I am on the page. Distribute, move things. Actually, I'm going to flip to this right here. So distribute right here, move things so you have x's on one side, non-x's on the other, and then divide, and your answer is 11. 11 does check. You should check your answers. Okay? All right, so with that idea, I could either, on this next problem, multiply through on both sides by 2 and x plus 3. If I multiply that on both sides of the equation, I will get x times x plus 3 equals 2 times 14. Okay? That is the same thing I get if I cross multiply. Bad term. Not descriptive. Okay, and then you distribute, and then that's a quadratic. I'm going to show you on the next slide. So you get a quadratic, you factor, you solve, both of those do check. All right, in the next problem, this guy right down here factors to these two pieces. So, if we multiply through by, and I mean this on both sides of the equation, if I multiply on both sides of the equation by x plus 2 and x minus 5, hard to show that right there, but hopefully you understand what I'm saying. A little bit of lack of space issue, okay? So, actually, maybe I'll just write that. Okay, so we're just going to use this. Okay, so if I take this whole quantity times this fraction, the x minus 5 at the bottom is going to cancel the x minus 5 over here, and you'd have this. All right, new color. If you take this expression times this fraction, the x plus 2 would cancel the x plus 2. And you'd have the 3 from the top and the x minus 5. And here's the best of all. This cancels all of that because those are the same thing. When you factor that bottom, you have the thing that's in the green circle. So you're just left with 7x. Okay? So when you multiply through, you should end up with a line that doesn't have like ratios anymore. You shouldn't have x's in the denominator. That just should not be a thing anymore. And that's true up here too. Back in number 25 when we talked about multiplying through by this, that removed the fractions, right? You came to a step. This next step doesn't have fractions, doesn't have ratios in it anymore. So when you get rid of the fractions, there should be no more fractions. So if you have fractions still, something is wrong. Okay, so from this stage, it's old math, not new math. X squared plus 2x plus 3x minus 15, all from distributing, Combine like terms, move the 7x to the other side. And to finish this, you're going to have this quadratic, factors, you solve it. This 5 does not work because if you come back up here and you substitute in 5 right there, problem, dividing by 0, not allowed. Okay, so 5 is what we call an extraneous solution. I would want you to show it exactly how you see it here, right? I found the 5, I rejected the 5. That's what we want to see. All right, and then the last one in this little chunk, I notice here that this denominator is a difference of squares. And when I factor that difference of squares, I'd have x plus 9 and x minus 9. Well, that's just awesome. So here, I just need to multiply through by that. I need to remember that difference of squares is going to get canceled out by both of these. So this cancels with that when I'm distributing it to this fraction. So I just have the 12. This fraction times these. The x plus 9 would cancel. I would just have x minus 9. This minus is here. This 2 is here. But the x minus 9 and the x minus 9 cancel and just leave me the x plus 9. Okay, and then you just distribute the negative 2 and solve it from there, which I have over here. Okay, distribute the negative 2. A common place for a sign error would be this one. So if you got the question wrong, it might be that you had a sign error right here. This negative on the 2 goes with both bits. And then solve. Okay, this next part says find all the things, basically. Okay, so I'm going to use my answer slide, I think, for this one and just talk it out. Okay, so I'm going to jump around as well. The vertical asymptote comes from looking at this bottom part and saying if that bottom part were 0, that would be illegal. Work it out, work it out. I cannot have x be 2. Okay, if x is 2, I'm dividing by 0. So 2 is my vertical asymptote. And because there's a vertical asymptote there, that's a split in my domain. The domain splits at 2. Then x-intercepts are when y equals 0. So I would look back to my equation. I want to put a 0 right here for y. And if this fraction is equal to 0, that's the same as saying the top part has to be 0. Right? The only way to get an answer of 0 in a division problem is if the first number is 0. 0 divided by something not 0 equals 0. Like 0 divided by 5, 0 divided by 7, 0 divided by 1, 0 divided by pi. All equals 0. So if my answer is 0 in a division problem, which is what this is, division problem. If I have a division problem with an answer of 0, that means the top is 0. Okay, so work that down, and x equals a third. So that means that's my x-intercept. Then come over to the right side, and horizontal asymptotes can be found with a vertical shift or by looking at these leading coefficients. So my leading coefficients are 3 and negative 3, and that ratio is negative 1. So I have a horizontal asymptote at negative 1, and so that means my range splits at negative 1. And my y-intercept is what happens when x equals 0. So put in 0 for both x's, work that out, and that's your y-intercept. Question 30 is the same kind of question. Exactly. I don't know what else I would say. You do the exact same thing. If you were confused and you don't think that it helped you enough to explain number 29 and then tell you number 30 is the same, you can contact your teacher or me. Even if I'm not your teacher, you can yell at me. It's fine. Okay, we're to the last couple questions, and these are story problems, which is fun because then you can say, oh, this is how people would use this math, which is great. So it says there's a volleyball team that's thinking about its record. It wants to get into a certain end result at the end of the season. So they have so far won 14 out of 21, so they're pretty decent, right? They want to know how many matches they'd have to win in a row, of their next games, to get from where they are now, which is winning 2 out of 3, so 67-ish%. They want to get up to 80%. That's quite a shift. Okay, that's a lot of shift. But we'll just see. We'll see what they have to do. So let's have X equal the number of additional wins in a row. And because we're saying they're winning them in a row, that's also going to be the number of games that we're going to add on. Okay, also the number of additional games. And so it's not like we're looking at the situation of they win the next one, but then they lose the next two, and then they win the next four, and then they lose one. We're not looking at that. We want them to like win, 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 win. And if they did that, how many wins would they need to bring it up to 80%? So I know that percentages are related to decimals, and 80% is a ratio of 0.80 or a decimal of 0.80. And that ratio is wins to games. So far they have won 14, but they're going to have to win some more. And that would be out of the total of how many games they've played. And right now, they've played 21 games, but they're going to have to play X more games. So the games that they have, we're saying they're going to win them all. So that X applies to the wins and the X applies to the number of games. Okay? So I'm going to take that one. Looks so weird. Okay, now I made it worse. Okay, so 21 plus X is what I'm going to multiply by on both sides. If I multiply by 21 plus X on this side, it would cancel out the other one. And I would get this equation. Then I'm going to distribute and solve. So that's here. Distribute, I get this. Put all the x's to one side. So 1x minus 0.8x is 0.2x. Subtract the 14 to this side. You have 2.8. And it turns out they have to double how many wins they have. They have to do 14 in a row. Now, if I wanted to double check this answer, something I could do would be to say, well, they have 14 wins right now, so that means they'd have 28 wins. After all is said and done, and they just had 21 games. And if they win the next 14, that would be 35 games. And so I would check that 28 out of 35 is the 80% that I want. And in fact, that's a decent fraction to deal with. Both of these divide by 7. So that common factor can come out. Is 4 out of 5 the same as 0.8? It is. Okay, so our answer checks. All right, now, like many people, you might be really into cooking lately. I know I've been making way too many chocolate chip cookies in my house. Anyway, if you get really into cooking, you start getting kind of fussy about your ingredients. So let's say in your cupboard, you have 3 ounces of an inexpensive type of vanilla. You know, it's like the grocery store brand, and it's kind of like diluted, okay? So you have this inexpensive kind of vanilla. It's only 70% vanilla, 30% filler. But this fancy recipe you're making, very fancy, says that you need to have vanilla that's at least 90% in concentration. Oh my. So how many ounces of pure vanilla? You have to go buy some pure vanilla. How many ounces of pure vanilla do you need to add in order to make a blend that is 90%? So you might do this, right? To kind of like, it's the fancy vanilla, you're going to mix it with cheap vanilla, get a decent kind of vanilla without having to like waste all of your pure vanilla. That's the thinking anyway. All right, so how do we set this up? We set it up like this. I have my vanilla curtain here. It's a vanilla colored screen. Woo, vanilla. Okay, so over on the left, you see I have 0.9. Why would I have 0.9? You're right, that's the concentration, that's 90%. Oh, it's kind of like in the volleyball, like this was the 80% right here that I had. So this 80% is kind of like this 90%. I see. Okay, so I want a 90% concentration, and when I do, when I want to have this like amount or this, it's sort of like a fraction, but it's written as a decimal. When I have this decimal, I want to do part over whole. So the part is I have 3 ounces at 70% concentration. I'm going to add X ounces at 100% concentration. Okay, now wait a second. Why is 100%? 1.0. Well, 70% was 0.70, right? You move the decimal point over 2 places. So here, if I move it over 2 places, oh, I see. So it's the same rule, it just looks weird to me. Okay, so 70%, 3 ounces at 70%, and X ounces at 100%. That's going to be how much vanilla I have out of, and this is how much fluid I have. I have 3 ounces plus X more ounces. So this is the part that's vanilla over the total amount of fluid. Okay, multiply both sides by 3 plus X. Gather the X's, gather the non-X's, and solve. Now, if you weren't sure if you were right, you just test it out in the question, right? So if I add 6 ounces of pure vanilla, wow, that's a lot, then I would have 9 ounces of fluid, right? Because that's what this bottom part is. And then I would say I have 2.1 ounces of vanilla in this part. And then I have 6 more ounces. So that's the equivalent of 8.1 ounces of vanilla. 8.1 out of 9. Is that going to be 90% or 0.9? Yes, it is. All right, so that math checks. All right, it's been a wonderful year. Thank you for studying with me tonight. I really appreciate it. Don't hesitate to reach out to your teachers if you're confused about anything. We want you guys to rock this last test and really end on a high note. Thanks so much.